Welcome to the chemical reaction type lesson. Okay, so a lot of this is supposed to be reviewed from grade 10, but we'll just start from scratch and kind of go through it again. I'll just go through all the different types of reaction types, and then your goal today is to, when you're given a chemical reaction, can you identify what type of reaction type it is? Okay, so we'll go through the steps here. So the first one we're going to study here is synthesis reaction. So this is where we will have a couple different reactants. They will combine together and form one product. Okay, so here's the visual, here's the description, and then we have an example column here. So if you look at sulfur here, an oxygen molecule, when they react together, they combine to make one product. Zinc and sulfur, zinc sulfide, etc. Okay, so here's calcium oxide and water. They ended up making one compound here, calcium hydroxide. So this is the synthesis reaction. So think synthesis, you're creating something. Okay, so you're taking a couple pieces together and then making it into one product. Okay, so look for that. Look for those details when you're trying to identify some later. All right, so here's the next one. We have a decomposition reaction. So this is where you're going to start with one reactant and they will break apart. So it's the opposite of the synthesis reaction. Okay, so decompose, break down. So we will have one product here, this compound, or one reactant, sorry. This is a compound here and it will break apart into a couple of different pieces here. So in this picture example, there's a couple products formed, but you can have more than two products. So in this case here, we'll have, so this hydrogen carbonate, okay, or carbonic acid, is breaking down into water and carbon dioxide. Okay, so as we go along here, so the one reactant, two products, one reactant, two products. Here, sometimes this confuses people when you have energy. We're not really gonna study this a lot this year, but you will study a lot next year where we're going to look at different aspects of a reaction that need to help it along, maybe go faster and so forth, or things that are produced. So right now we're just looking at the reactants and the products, but every once in a while you might see a chemical reaction equation that has like an extra piece like energy in it, or energy on this side. So just it's not a reactant. You don't have to balance this or anything, but just kind of look at this other part here. It's breaking into two here. So that's how you know it's decomposition. All right, the next one here is single displacement. So again, what you're going to find is one element will come in and it'll react with a compound which already has, like a metal, non-metal, and it'll come in and displace one of them, okay, or displace the same one. So if a metal comes in, it'll displace a metal. If a non-metal comes in, it'll displace a non-metal. So here A comes in, displaces B, okay, grabs C, and then B gets kicked out, okay? So it gets displaced. They also call this a single replacement reaction, so you'll see that as well. All right, so taking a look at the examples here, we have zinc comes in and approaches copper sulfate here, and then knocks out the copper, takes up sulfate, it makes a compound, and then copper gets kicked out, okay? So that's a single displacement reaction. Okay, move on to the next one here. So then there's something called the double displacement reaction where a compound comes in, reacts with another compound, and what happens is the metal and metals, they'll swap places and they'll grab the other non-metal. So A comes in here, it's partnered with B right now, comes in and ends up knocking C out, grabs D here. So AD becomes a compound and CB becomes a compound. So they just kind of swap places here. So it's a double displacement. Okay, above it was single because just one metal or one element came in and displaced another element. So metal for metal or non-metal for non-metal. Here it's they swap places here. Okay, end up with two compounds. So it's a double displacement, or they'll call it double replacement reaction. So looking at the examples here, sodium hydroxide, hydrogen chloride here, so hydrochloric acid. So you'll see the sodium and the hydrogen will swap places. Okay, so sodium will grab chlorine now, and then the hydrogen grabs the hydroxide, which is the same as H2O, which is water. Okay, and the next one here, element combustion reaction. So combustion, think of as burning and so forth. So just think of a fire, you need oxygen to burn. So whenever you see oxygen as one of the reactants, so again, one of the ones on the left side, right away, you should clue in that, oh, we have a combustion reaction here. So there's a few different types of combustion reactions. So these are the things that might be new this year. So you would have covered synthesis, decomposition, single and double displacement reactions. You may have touched on combustion last year, but not to this detail. So I want you to be able to identify the element combustion reactions this year. So basically an element will come in, react with oxygen, and then create, like, so if it was a metal oxide. If it was a non-metal oxide. So take a look at these examples here. So we have magnesium's a metal, reacts with oxygen, makes a metal oxide, magnesium oxide. Here's phosphorus, a non-metal comes in, reacts with oxygen, makes a non-metal oxide. Okay, and again, don't worry about the energy that's popping out here. So that is an element combustion because an element is coming in, reacting with the oxygen. Okay, so then here you have hydrocarbons. So you're going to see in the next video that I've attached, you can get, so they call it hydrocarbon because you get a hydrogen and a carbon compound, but you can also get a hydrogen compound and hydrogen carbon and oxygen compound as well. So if you have these ones coming in, again, you're going to see oxygen's that other reactant. So again, it's on the left side. If it pops out on the right side, doesn't mean it's combustion. It's just you got to see it on the left side, one of the starting materials. So you're going to see it come in, and you'll see the carbon dioxide and water pop out. So again, I think this is what, if you did do combustion last year, you would have studied this. So carbon dioxide and water are the products. Okay, so this is what makes it a complete combustion versus incomplete. So if it's a complete combustion, it's a nice clean burn. You're not going to get these other byproducts of certain stuff coming out. So if you get a hydrocarbon, react it with an oxygen, you're going to get carbon dioxide and water. Okay, so here is methane reacting with oxygen, producing carbon dioxide and water. If you don't have a nice clean burn, so if you have not enough oxygen getting to the hydrocarbon, you're going to get these byproducts forming. So here is an example of an incomplete combustion. So you have a hydrocarbon burning, combusting in the oxygen, producing carbon dioxide and water still, but then you're going to get these byproducts. So if you ever see anything else in the reaction equation, you can go, okay, that's combustion because you have the oxygen, but then you have these extra byproducts. So here in this case, we have carbon monoxide, and we have just carbon, which is the soot. Okay, and then here's an example here that you can kind of look at as well. Okay, so now that we've gone over the chemical reaction type notes, let's try some practice questions here. So I'm going to throw some examples at you here, and I want you to identify what type of reaction it is. And keep in mind that you could have more than one answer for, I think, one of them there. Okay, all right, or a couple like that I see. So start with the first one. So we have copper. Okay, copper 2 carbonate coming in and producing carbon dioxide and copper 2 oxide. Okay, so we're noticing here we have one reactant and then we have two products. So here one broke apart, so it decomposed. So we have a decomposition reaction. Okay, so this one was a decomposition reaction. All right, let's move on to the next one. We have iron plus sulfur makes iron sulfide. Not sure which type of iron it is. We need to run it through a machine to figure out if it's iron 2 or iron 3. So anyway, so we have this compound here. We need to figure out what kind of reaction type it was. So I'm noticing that we had a couple of reactants. It became one product. So that is a synthesis reaction. Okay, move on to the next one. Number 3, so we have lithium and oxygen makes lithium oxide. So again, we had a couple reactants, became one product. So right away, synthesis reaction. Okay, but hopefully alarm bell kind of went off and when you saw the oxygen there as one of the reactants. So again, if oxygen's on the left side, okay, that is a combustion reaction as well. So to get full marks for something like that, you need to write both of the reactions. Okay, move on to the next one, number 4. So you're looking at zinc coming in, and you have a metal, you have a lone element coming in into a compound here, and then you analyze the products on the other side, and you notice, oh, look, they swapped places. Okay, so because one lone element came in, this is why they call this a single displacement reaction. Okay, so that's what you're looking for. One element comes in. Okay, also, or single replacement reaction is also acceptable, depending on what you learned last year. Okay. All right, from there, move on to the next one. So we're seeing again, so it looks like it's like a couple, maybe this is a compound, it's an F2, but remember there's diatomic molecules out there, okay, so it's still considered like an element, okay, even though it's diatomic. So this halogen, fluorine, is coming in, and it's displacing a fellow nonmetal, okay, so you're not going to displace the sodium, you're going to displace the other nonmetal, which is chlorine. So always pay attention to that. So like in number 4, we saw the metal come in, it replaced the metal. So for number 5, the nonmetal comes in, it replaces the nonmetal. So fluorine and sodium will now become a compound, but we write the metal first, sodium fluoride, and then the chlorine gets kicked out. So this is a single displacement as well. Okay, or displacement reaction. Okay, so yeah, you can have a metal come in or a non-metal come in, so just pay attention to that. All right, number 6. So we have sodium hydroxide and iron 3 nitrate coming in, reacting together. A reaction does proceed, and you find that, oh, look, they swap places. So the sodium and iron swap places. Okay, so sodium used to be with hydroxide, it is now with the nitrate. Iron is now with the hydroxide, okay? Or some people look at it as, oh, the polyatomic swap places, okay? So either way, 2 compounds came in, they swapped, so this is a double displacement reaction. Or some of you might know it as a double replacement reaction. Okay. Move on to the next one. So we have potassium. Okay, so you're looking at that. Okay, that's a metal. It's just a lone element. It's coming in. Oxygen is a reactant, and it's making potassium oxide. So again, 2 reactants formed 1 product, or hopefully you also saw, oh, there's that oxygen as a reactant, so combustion. So again, this one has 2 reaction types. You need to write both of them in order to get full marks. Okay, and on to the next one, number 8. So again, hopefully you see the oxygen right away and you're like, oh, it's a combustion reaction. Okay. And so what else did you see here? Well, so of the combustion reactions, I didn't really specify what kinds they were. So if you look back up to number 3 here, so remember it was a metal that came in, so you can just call it like an element combustion reaction. Number 7, potassium, a metal came in, so that was just an element coming in. All right, but here it's a hydrocarbon, so call it a hydrocarbon combustion reaction. But on top of it, see how the products are both carbon dioxide and water. So if it's a nice clean burn, you're just going to get these products. If you don't have a nice clean burn, we're going to analyze that in a few lessons. You're going to get these other byproducts coming out. Okay, so hydrocarbon, this is a complete combustion. So to get full marks, you want to say complete combustion reaction. Okay, I won't pick on you so much if you don't write hydrocarbon, but as long as you write complete combustion reaction. Okay, with the other ones here, you have the element combustion reactions, and then this one here, You have a hydrocarbon with oxygen, so right away combustion, but then because you have these extra byproducts, it's a hydrocarbon incomplete combustion reaction. So let's copy this here. Okay, but remember to write incomplete. Okay, so it's not, it's basically, it's not getting enough oxygen to burn purely enough so that it's producing these other byproducts as well. Okay, so that is your reaction type lesson for today. Okay, so I want you to try, I have an activity that you can try if you want. I know some of you work better if you can kind of move things around with your hands and so forth. So I'll show you what that looks like here. So if you look through the class schedule for the lesson today, you'll find the reaction type envelope activity. So what you can do if you work better with like being able to kind of cut stuff and move stuff around with your hands. If you want to take this sheet, cut up each of the reactions. So you'll have all these word equations. Then you'll have some skeleton equations, and then for just some visual equations as well. So just think of like each different symbol as being an element, and then if they're stacked together, they're a compound. So if you have a compound and it breaks into two different pieces here, what kind of reaction type is it? Okay. Yeah, so that's the part. Cut it up. So just like keep these pictures together. That's another one. Cut all the reactions apart, and then just get yourself a big table area or maybe the floor to work on. And then the other one I want you to grab is, again, if you don't have a printer, just copy them out and you can write it into your notebook. Here is the foldable that comes with this activity. So basically you can glue these into your notebook or onto a piece of paper, but if you wanted to just kind of have like one little sheet where everything's there, you can have a synthesis area, decomposition, a single displacement area, double displacement, and combustion area, and just kind of go through, cut and paste those pieces, and then at first just kind of put them into the right spots, okay? And then I do have the answers up for this activity so that you can double check, and then when you're good you can glue it down, and then you have some notes that you can refer to. Okay, so once you complete the cut and paste activity, or if it's not your thing and you don't want to do it, you can go right to this worksheet. I also have it up in the class schedule right now. So this is a worksheet. So what I want you to do is go through and just go through and identify the chemical reaction types. So here, if you wanted to look through the instructions here, so like if you're trying to figure out if it's a combustion reaction, here's some key questions you can ask yourself. So does the reaction have oxygen as one of the reactants? Are you noticing carbon dioxide and water as its products? Okay, so then you know it's a combustion reaction. Okay, 2, if your reaction has 2 or more chemicals, they combine and make one chemical, right? Makes one product. You have a synthesis reaction. 3, does your reaction have one large molecule breaking apart, falling apart into small, lots of little ones? Then you have a decomposition reaction. 4, if it only contains one element, like one of the molecules, like you have one element come in, it displaces, and then you have one element coming out, then you know it's a single displacement reaction. If you have, then it says here, if you didn't answer yes to any of the above, then it's by default this double displacement. So you're going to see the 2 compounds coming in and swapping places. Okay, so anyway, so here is a worksheet that you can try. I want you to practice your balancing your equations as well while you're going through. So start off with just maybe going through, tell me the reaction types. So, and then just write it on here. And then here's another page. So here, so those are the reactions. Here, these ones are already balanced. So just go through, tell me what type of reactions that they are. Again, I know up here at the top it just said, oh, write combustion, but try to get fancy here and try to write the specific type of combustion reaction it is, whether it's an element combustion or if it is a complete combustion. I don't know if I put any incomplete ones on here, but you know to look for the carbon dioxide and water. yeah, I don't know if there's any incomplete, but anyway, so just be ready for any incomplete reactions as well, like especially on your checkpoint, and any future assessment questions. So yeah, so just go through your key. The key to this lesson today is to identify the reaction type, but then I do want you to be good at balancing equations as well. So go through after that and balance the equations to get extra practice, and for 1 to 8, and then the next page they already balance. You don't have to do it there. And then please check the answers. So please be going through the video, then look at the notes, then go through the worksheets, go through any activities, practice a little bit, and then try the checkpoint. A lot of you were trying the checkpoints last week. Just winging it, I think, after watching the video. So I just want you to just have a good, comfortable understanding before you tackle the checkpoint, because that's the only way I can check right now to see how you guys are doing. So, okay, so once you feel confident, just go and work on the checkpoint. I put it in the assignments box, so just complete it and then hand it in there, and then you can move on to the next lesson or just take a break for the day. Okay, so thanks for watching.